The 1940s and 1950s marked a period of immense intellectual curiosity following World War II. Scientists and mathematicians, inspired by wartime advancements in computation, began to ponder the possibility of creating machines that could mimic human intelligence. This era saw the birth of the term artificial intelligence in 1956 at the Dartmouth Workshop, a pivotal event that brought together leading thinkers like John McCarthy, Marvin Minsky, Alan Newell, and Herbert A. Simon. These pioneers envisioned AI's potential to revolutionize various fields. The ensuing years were characterized by a wave of optimism. Early AI programs like Newell and Simon's Logic Theorist in 1956 and General Problem Solver in 1957 showcased the ability of machines to solve logical problems and even play games like checkers at a superhuman level. This fueled excitement about the future of AI, with predictions of human-level artificial intelligence on the horizon. However, these early successes were limited to narrow domains. The programs lacked the flexibility and adaptability of human intelligence, struggling to handle complex real-world situations. Despite the limitations, this period laid the groundwork for future AI research, establishing key concepts and approaches that would shape the field for decades to come. The seeds of future innovation had been sown. The 1970s witnessed a period of disillusionment and reduced funding for AI research, often referred to as the AI winter. The initial wave of optimism collided with the reality that achieving human-level AI was far more challenging than initially anticipated. Early AI systems, while impressive in their limited domains, struggled to generalize their knowledge to new situations or learn from their mistakes effectively. One of the main reasons for this setback was the limitations of computing power at the time. AI algorithms, particularly those based on neural networks, required vast amounts of data and computational resources that were simply not available in the 1970s. This hardware bottleneck hindered progress in developing more sophisticated and capable AI systems. Moreover, researchers encountered fundamental challenges in representing knowledge and reasoning within AI systems. Early approaches often relied on symbolic logic, which proved too brittle and inflexible to capture the nuances of human language and common-sense reasoning. These limitations led to a decline in funding and interest in AI research as expectations failed to meet reality. The 1980s saw a resurgence of AI research, driven in part by the rise of expert systems. These systems aimed to capture the knowledge of human experts in specific domains such as medical diagnosis or financial analysis. Expert systems proved highly successful in certain applications, providing valuable insights and decision support. They demonstrated the commercial viability of AI solutions, leading to renewed investment in the field. Parallel to the development of expert systems, research in neural networks gained momentum. Inspired by the structure of the human brain, neural networks are composed of interconnected nodes that process and transmit information. While early neural networks were limited by computational constraints, advancements in computing power and algorithmic techniques allowed researchers to develop more complex and capable models. The 1990s witnessed significant milestones in AI research, particularly in the realm of machine learning. Researchers developed new algorithms such as support vector machines and convolutional neural networks, which enabled computers to learn patterns and make predictions from data with increasing accuracy. These advancements led to breakthroughs in areas like image recognition, natural language processing, and robotics. The 21st century ushered in an era of unprecedented progress in AI, fueled by the rise of deep learning. Deep learning involves training artificial neural networks with multiple layers, allowing them to learn complex representations of data. This approach has revolutionized fields like computer vision, natural language processing, and machine translation. The availability of massive datasets coupled with exponential growth in computing power has been instrumental in the success of deep learning. Algorithms can now learn from vast amounts of data, identifying intricate patterns and making highly accurate predictions. This has led to breakthroughs in areas like image recognition, where AI systems now surpass human performance on certain tasks. The rise of generative AI in the 2020s has further expanded the capabilities of AI systems. Generative AI models such as GPT-3 and DALL-E 2 can generate human-quality text, images, and even code. These models have sparked both excitement and concern, raising ethical questions about the potential misuse of such powerful technology. As AI becomes increasingly integrated into our lives, it is crucial to address the ethical challenges it poses. Bias in algorithms, job displacement, and the potential for misuse of AI systems are all pressing concerns that require careful consideration and mitigation strategies. The future of AI depends not only on technological advancements, but also on our ability to harness its power responsibly and ethically.